In this video, we are going to be solving one-step equations with rational numbers. So now we're going to put together the concepts we learned in the last couple of videos, solving addition and subtraction equations, solving multiplication and division equations, and now we're going to put those both together and solve equations that contain more difficult numbers like fractions, mixed numbers, and decimals. So our only essential question is, how do you solve one-step equations with rational numbers? So how do you do that? We're going to do the same thing we did with our integers, and we're going to undo the operation performed on the variable by using our properties of equality. Now, the properties of equality still work with rational numbers just like they do with our integers. So we're going to try to undo any operation that is happening to the variable so that we can solve our equation. A couple examples: x plus 2/3 equals 5 1/4. Now we're getting into equations that aren't mental math anymore. They definitely aren't mental math. So we have to have our strategy for writing down these equations and solving them. And that's why I've had you practice these with our integers and our simpler equations, because now they're getting a little bit more complex. So we're going to solve these using the same strategies we did before, using our properties of equality to undo these operations. So if we're looking at the side that contains the variable, x is having 2/3 added to it. So what we want to do is we want to undo that. So what I did was I subtracted 2/3 from both sides of this equation, and then these two terms are going to cancel each other out. That's just going to be 0. X plus 2/3 minus 2/3 is just x, and then 5 1/4 minus 2/3 gives us 4 7/12. So we've solved this equation. X is equal to 4 7/12. And if you check that like we always have, 4 7/12 plus 2/3 is 5 1/4. So that is our solution, and we know we're correct. So when in doubt, always plug that solution back into the original equation to see if you got it right. Next one is a multiplication problem with decimals. Here we have 5.8h, which means 5.8 times h equals 18.56. And again, h is being multiplied by 5.8, so I want to undo that operation using the opposite or the inverse operation. So the opposite of multiplying by 5.8 would be dividing by 5.8. So that's why I divided by 5.8. And what I do to one side, I have to do to the other. So 18.56 divided by 5.8 gives me 3.2. And then these two operations will undo each other, and all I'm left with is h on the left-hand side. So h is equal to 3.2, and then as always I check that, and 5.8 times 3.2 is 18.56, so that is my solution. So you can see it's very similar to what we've done before, just now we're dealing with some more complex numbers, and we have to have a strategy for solving them other than mental math. So here, let's solve these equations. H divided by 4/5 equals -5. So again, the first thing I'm going to do is divide my equation into its two halves, and then I'm going to look at the side that contains the variable. H is being divided by 4/5, so I need to use the opposite operation to undo this. So what's the opposite of dividing by 4/5? Multiplying by 4/5. So that's what I'm going to do to both sides of this equation. So I rewrite my expression on the left-hand side, and I'm going to multiply by 4/5, and then I'm going to rewrite the right-hand side and multiply by 4/5. So I've multiplied both sides of this equation by 4/5. These two are going to cancel each other out, and all I'm left with is h, and -5 times 4/5 is -4. And if you plug this value back into the original equation, -4 divided by 4/5 is -5. So I know that solution is true. Next, -19.78 equals k plus 5.8. So again, I'm looking at both sides of my equation. The side that contains the variable, k plus 5.8, I'm adding 5.8 to k, so I need to undo that. So the opposite of adding 5.8 would be subtracting 5.8. So that's what I'm going to do to both sides. I'm going to subtract 5.8 from both sides of this equation. I'm not sure why it's doing that. Let me start that one over. Sometimes my pen doesn't cooperate with me. -19.78 minus 5.8. K plus 5.8 minus 5.8. There we go. So -19.78 minus 5.8 is -25.58. And then these two terms are going to become 0. They cancel each other out. So all I have is k. So negative 25.58 is equal to k. There's my solution. And again, if I put that value back in the original equation, negative 25.58 plus 5.8 does give me negative 19.78. So I know that my solution works. Always go back and check your solutions. It only takes a second. Next, negative 6/7 times b equals negative 18. Again, I'm going to divide my equation into its parts. B is the side I'm looking at here. This is multiplied by negative 6/7. So the opposite or the inverse of that, I'm going to undo that by dividing by negative 6/7. So I need to divide both sides by negative 6/7. These will cancel each other out. I'm left with 1b, and then negative 18 divided by negative 6/7 is a positive 21. So there's my solution, b equals 21. And then again, if I come back and plug that into the original, negative 6/7 times 21 does give me negative 18, and I know that my solution is correct. Next, d minus 23.4 equals negative 18.99. Again, divide this equation into its two halves, and then I look at the side that has the variable d minus 23.4. So I need to undo subtracting 23.4. So I'm going to add 23.4 plus 23.4. And then I'm going to add 23.4 to both sides, negative 18.99 plus 23.4. These terms cancel each other out. D equals negative 18.99 plus 23.4 is a positive 4.41. And there's my solution. And then as always, if I plug that back in the original, 4.41 minus 23.4 does give me negative 18.99. So I know that that is true, and that is my solution. Here we have t divided by negative 7.75 equals 0.5. Divide my equation into its two parts. On the left-hand side, t is being divided by negative 7.75. So the inverse or the opposite of that, I'm going to undo that by multiplying by negative 7.75. So that's what I need to do to both sides here, is multiply by negative 7.75. And when I do that, these will cancel each other out. T is equal to, and then 0.5 times negative 7.75 is negative 3.875. And there's my solution. T is equal to negative 3.875. And as always, if I plug that back into the original equation, negative 3.875 divided by negative 7.75 is 0.5. I know I got the solution correct. Last one, we have z minus 5 3/5 is equal to 22 1/3. Again, if I divide my equation into its two parts, I'm looking at the side with z. We are subtracting 5 3/5 from z, so I need to undo that by adding 5 3/5 to both sides. So that's what I'm going to do. Minus 5 3/5 plus 5 3/5 is equal to 22 1/3 plus 5 3/5. And then these will cancel each other out. That's just 0. So z is equal to 27 14/15. And that is my solution. And again, if I check that, I put that back in the original equation. 27 14/15 minus 5 3/5 equals 22 1/3. That is true. So I know my solution is correct. So solving these one-step equations with rational numbers, it does require you to write this stuff down and show your work, because this is no longer mental math. So make sure you're using the opposite operation and the properties of equality to solve these equations with rational numbers.